So we're talking about phases of matter. Okay. Talk about phases of matter. How many phases of matter are there?
1, 3.
There's 5.
Oh.
There's 2 you probably never heard of. Okay? We're going to focus on the main 3, but you're going to be exposed to all of them. Okay? We're going to talk about all of them. But for as far as what we're going to work with, it's going to be the main 3. So first, we're going to talk about the highest energy form. You don't have to. Leave your notes. What are you going to do? We're still talking about matter, so. Does anybody know what the highest energy form of matter is? Plasma. All right. Plasma is, like I said, is the highest energy form of matter. It's ionized gas. What do I put gas in quotes? No, it's not really a gas, it's a plasma, but it behaves much like a gas. Okay, so gas is what you're most familiar with, right? So just think of that, but a really hot, really corrosive, reactive gas. We're talking about thousands of degrees. Okay, that's how hot. Now, what does ionized mean? Anybody know? What? No. Anybody else? It's charged. Okay, it has a positive or a negative charge. What happens is the particles in a plasma are moving so fast, and they have so much energy, and they're so hot that it strips the electrons away. So it's a charged gas. Okay? It strips the electrons away from the atoms. So you have these positive parts, the nucleuses, the nuclei, running around, and then you have the electrons separated. Okay? And that's what makes them so reactive. Okay? And so they have so much energy, it just kind of blows them apart. Does anybody know where you see a plasma? A plasma TV. Where else? Cole, you see one every time you're in the ag shop.
That's what a plasma cutter.
Plasma cutter, yeah. The stream it puts out is a plasma. A welder, the arc, bolt of lightning, the part that you actually see, the flash, is a plasma. The flash and the lightning, okay, is plasma that you're seeing. The northern lights, aurora borealis, that's plasma. It's caused by the solar wind interacting with the magnetic field of the Earth. Okay, produces those lights, which are plasma. The sun has plasma in it. It's that hot. Those are all places you see plasma. Good. Any questions? Main thing I want you to get out of this is it's the highest energy form of matter, and you still kind of know what it is. All right, that's all you really need to know about plasma. We're not going to study it a whole lot. Questions about it? All right. So,
Cut through anything?
what's that?
Can plasma cut through anything since it's the highest energy? Like, I don't know. I'm just like,
It reacts with a lot of things. Okay? The only way to really contain it is with a magnetic field. Because in fusion reactors, nuclear fusion reactors, they use magnets to contain plasma to get the fusion reaction going.
Like, you get it small enough where, like,
Well, it starts because fusion is putting together, right? So nuclear fusion are trying to squeeze it together. They use the magnets to squeeze it because nothing else can really hold it. Because it eats through everything. Does that make sense? That's why you use the plasma cutter, because it busts through steel and everything else. All right, and you have to use, they won't can use that on electrically conductive things. It's the only thing it'll cut through because it has to conduct electricity through it. All right. If plasma's the highest, What's next down?
I don't know.
What's still high energy but not as high energy as plasma? What phase of matter? Gases.
So gas is second.
The next highest energy, yes. Okay? Gases have what's called an indefinite shape. And volume. What does the word indefinite mean?
Not defined, like liquids. You say it was indefinite.
The liquids were indefinite shape, but they have a definite volume.
They don't have the same shape. And
They take the shape of whatever they're in.
And so like
Yeah.
say, if it was a square, it would be square. If it was a circle, it'd fill up the circle.
Right. That's the indefinite shape.
Yeah.
Not defined. It's not fixed. Definite doesn't mean it's fixed, but it means it holds a shape. Yeah. Now, what about volume? It's going to fill up whatever container it's in, right? It could change density. So, like, the air is not just in this part of the room; it fills up the whole room, right? So that's because it's indefinite volume. Because it has an indefinite volume, it's compressible.
you compress it air.
Oh yeah, yeah.
Compressible means you can compress it, right? You can squeeze it. Air compressors do that. It looks like tires work. Okay, it makes them bouncy. You can compress them. It's the reason we have air in our tires.
If they explode, it's bad.
True.
Is it right?
That's nasty.
All right. But you can compress it, make it increase the pressure.
See Dave getting ready to clean stuff up.
All right. What else do we know about gases? The particles move freely. And they are a fluid. Gases are fluids. Particles move freely, so they're moving around all over the place, aren't they? The air particles in here. How can we tell how fast they're moving? You can by taking a temperature. The amount of energy the particle has is directly related to its motion, how fast it's moving.
Hot.
Okay.
Fast.
If it's hot, it's moving fast. Correct. Cold, it's moving slow, just like you.
Like a snake.
Kind of, yes.
Swim that direction, nine.
So, the faster the particles move, the hotter they are, the more energy they have. So by taking its temperature, we can directly relate that to its energy. Okay, so how fast they're moving. What does it mean if something's a fluid? What is a fluid? Doesn't have to be, although liquids are fluids. Anything that flows is a fluid. Anything you can pour is a fluid. Does air flow?
Yeah.
Yeah, that's what wind is, right? That blow your mind, Montana.
That was what?
The wind moves, right? It flows, so it's a fluid. Right?
What?
Okay, what's the issue, Montana?
Nothing.
Okay.
That's
Okay,
It's
so
just mind-boggling.
So if it could flow, like air flows, if I have a fan, it's pushing the air, right?
yeah.
And so if I sit in here, it's flowing from you to me, or me to you, right? So therefore it's a fluid,
Got it.
okay? All a fan is an air pump, okay? So if I put a fan in the water, then it's a liquid pump, it's making the water flow. Same thing, it's a fluid.
Gotcha.
No, this is not a box fan.
What's that?
It's not gonna work.
Honestly, yeah,
If I set a box fan in water, it's gonna work.
for a while.
For like 2 seconds.
Why would the box?
You don't want to be in the water with it.
Yeah.
Maybe, yeah. They have electric motors that work
You
underwater.
wanna be in the water?
Then a box fan?
Well, not necessarily a box fan.
Well, I know that they have certain fans that do that, like
Yeah.
let's say turbine.
And we, yeah, any boat that has an electric, like a trolling motor,
It's just wind underwater.
Yeah, hey, moving water is wind underwater.
It's
True. All right. Questions about gases?
Nope, got it.
All right. What's next below a gas in energy? Liquid. Okay, now does the liquid have a definite shape? No. Does it have a definite volume?
Yes.
Yes. So when I pour tea into my container, it keeps its volume. It doesn't fill up the whole container no matter how much I pour, does it? Okay? It just keeps its volume. That's what having a definite volume is. I just reduce its volume. All right. Are gases compressible?
Yes.
No.
Liquids ain't
What? You
compressible.
said our gases.
Yeah.
No, sorry. Are the liquids compressible?
Yes.
No, they're not compressible.
No.
What? I think water isn't water the strongest thing in the
If you,
world.
if you.
Yeah, but it's gonna spread out. It's not gonna go away.
Right.
You put water.
It changes location, doesn't
You
it?
squeeze it.
There's still water in it.
It's gonna compress.
No.
It's pressing the water bottle, not the water.
Right. You're breaking the bottle, so it leaks out.
Isn't water the strongest thing in the world?
No.
What's the strongest thing in the
I
world?
don't know.
Yeah, I
Strong's
know.
a bad term.
Vibranium.
I know, but like, water could like, if enough of it, it's like, you can push down buildings.
Yeah, well, ice can crack sidewalks and stuff, concrete.
Yeah, I'm sure water could do the same thing if it already does.
Yeah. Okay, it's not compressible, and it is a fluid. They are. All liquids are fluids. Fluids. Right. There's a whole area of study called fluid dynamics that studies just how fluids move. Okay?
How can they study air moving if they can't see air?
You can see the evidence though of it moving.
Like if something's blowing, like.
Mm-hmm. That's what wind tunnels are for. They have a smoke that goes over the shape of whatever they're studying, and then you see how the gases are moving. And they do the same thing in the water. They use dye though in water, like for boats, to figure out the hull design. They'll use like not food coloring, but like a dye like that. Put it in the water and watch it go past the hull of the model that they made. And they have the water flowing. They have their box fan in the water. And they- All right. So instead of a wind tunnel, it's a water tunnel.
Water?
All right. You will have. I need to back up with gases real quick. You will have a whole unit over gases later on. It will be. You'll study gas laws about how they behave and all that stuff, how they expand and contract with temperature and pressure, and how you measure all that. All right. After liquids, what's less energy than liquids? Solids.
Turn the liquid into a
We'll get there in a minute. I promise you.
ice.
Oh, hold on, don't write solids. You haven't already. Forgot to add something.
Particles. Particle accelerator.
Particles are.
Yeah, you know, that's what it's called.
Yeah,
Okay, in liquids, the particles just slide past each other.
Oh, I don't have.
In gases, we said they were free to move. In liquid, they slide past each other. And still, their rate of motion, how fast they're moving, is based on their temperature. Montana. Leave Tay alone. Told you no PDA.
There is no PDA.
It's not infection, it's just.
He punched me.
Infection?
I hit him back.
So you
Affection.
if I were to punch you,
Affection.
you kick on my armpit.
Okay, do solids have definite shape?
Yes.
Yes.
Montana, stop being
Kill her.
Do they have definite volume?
Yes. You wanna know something? He's probably gonna mute the what's it called watching this video.
Why would I? I'm explaining stuff to you.
Well, they can read it.
Okay, but I'm saying stuff that's not.
Unless they're me, they can't
It's
read
not.
it.
All right. Are solids compressible?
No, it'd be-
I told you.
Octavius,
Actually,
why?
I didn't even
Quick.
stop him. I just corrected his face.
They're not compressible.
You can't compress a solid?
What's compressible?
Well, I guess because it's water, it's expanded water, and you crushed it.
It'd still be the same, still the same, still the same volume. Because compression means you're changing its volume. You can't change its volume.
Oh.
Just tell you when you compress something, you're taking its volume and making it less. You can't do that. That's
Because
all.
it's still the same
Yeah.
amount.
But if I cut a piece of this table off, it doesn't weigh the same.
But it's, but I'm saying, the density hasn't changed for the piece. Okay? Basically, yeah, it's not, there's no density change. Alright. It's not compressible, has a definite shape, definite volume. What are the particles doing?
Staying in one spot.
They're just vibrating. Right. But yeah, they're staying in one spot, but they're vibrating. Particles vibrate in place. And how fast they vibrate is based on their temperature. Questions about solids? All pretty familiar with those, right? Alright, now one you've never heard of, that's even lower energy than a solid, is called a Bose-Einstein condensate. Or Beck. It's the lowest energy phase. By Felicia.
Finally.
Get that finished, then you leave.
Yes, sir.
What is this on?
My video.
I don't